Hi everyone, I am Dr. A. Puriyesan, Associate Professor in Department of Biomedical Engineering from KSR College of Engineering. So in this video, uh, we discuss about block diagram, block diagram reduction techniques in control system. So there are some set of rules to reduce the block diagram. So first rule will be the combining the cascade or parallel blocks. Suppose two blocks are serial means G1 and G2, you can reduce by multiplying like that G1 and G2. Suppose two blocks are added or subtracted, you can put as G1 plus G2 or G1 minus G2 according to the symbol in the summer block. The next rule will be the moving the summing point behind the block. If we are moving the summing point after the G, we will add extra block as G. Next, for moving a summing point ahead a block, then you add 1 by G. We are adding extra 1 by G to the block. That will be the reverse case. If you are picking a point, you are behind the block, you are adding 1 by G. Similarly, you are moving a pickup point ahead the block means you are adding G extra. So for closed loop response, you have to eliminate. So G will be the block, H will be the feedback block. Here the symbols are plus, here the plus are minus. That means you have to reduce into G divided by 1 minus or plus H. That means here it will be the plus symbol, here G divided by 1 minus GH. If suppose here it will be the minus symbol, so you get G divided by 1 plus GH. Suppose in case of unity feedback, then H equal to 1. So in that case it will be G divided by 1 plus minus or plus G. So the last row will be the swapping of neighboring two summing points. You can swap the neighboring summing points. So these are the 7 rules that you have to follow in the block diagram lecture. So now we have seen an example. In that example, here the blacks are G1, G2, G3, G4, and we have two feedbacks H1 and H2. For reducing the black G1 and G2, here the additional pickup point will be the extra between the G1 and G2. So first step, you have to move the pickup point. For that, you have to use the rule moving the pickup point. So you have to move the pickup point from A to B. So you have to follow the rule. You are adding ahead. That means you are adding which block you are shifting G2. So you got to add extra block G2. Okay. Now you can reduce these three blocks. Now G1 and G2 are neighbors. You can multiply G1 and G2 plus G4. So you can add G4 plus G2 and G3 are combined together, G2 and G3. So finally you get like that. Now the pickup point B will be you have to move the pickup point. Now we are moving the pickup point from B to C. Then you are shifting the B into C. Then you are shifting the block of G4 plus G2 and G3. For that, you have to add 1 divided by G4 plus G2 and G3. You have to find the rule. Now this will be act as a feedback G divided by H. So it becomes G divided by 1 plus GH rule. So you have to follow the feedback elimination rule. then you get a G2, G4, G divided by 1 plus G into H rule. Now these two blocks are nearing, G1 and these blocks are nearer. You can multiply these two blocks, combine to these two blocks. So G1 and G2, then the remaining block will be act as a feedback lag. So again it will be act as a G divided by 1 plus GH rule. The finally have a single block with the unity feedback. So for that you have to apply the rule G divided by 1 plus G. You apply the rule G divided by 1 plus G. So you can finally get the answer G1 divided by G1 into G4 plus G2 G3 into 1 plus G1 G2 H1 plus H2 into G4 plus G2 G3 plus G1 into G4 plus G3. So these are example for reducing the blocks into a single block in the control system to find the transfer function of any system. Thank you.